Hey everyone, Stericus here, and today we're going to discuss an extremely important topic. As Al Gore taught us so many years ago, hurricanes are bad. They are really bad. They go very fast and they cause lots of really bad things to happen. Due to climate change, hurricanes are becoming increasingly frequent. What if there was a way to stop all hurricanes not caused by George Bush's weather machine? In today's video, we will examine a potential and permanent fix for these inclement weather events and call upon our legislators and public officials to take action. First, we begin with some fundamental atmospheric science. Clouds are made of water vapor. Hurricanes are made of clouds. Therefore, hurricanes are made of water vapor. It's the transformative property. But how does water vapor even get into the sky to begin with? Water can't fly. The answer is the sun. The sun bakes the surface of this cursed world with solar radiation, convincing tight-knit communities of water droplets to give it all up and move to Cloud City. And if you followed this so far, the logical solution to this problem is obvious. If there's no more water vapor in the sky, there's no more clouds. And no more clouds means no more hurricanes. But how do we go about this? Can we turn off the sun? Unfortunately, turning off the sun would actually be quite difficult, and according to my legal counsel, perhaps not even permissible under the laws of the United States. Additionally, solar radiation grows the corn that supplies us with our God-given high fructose corn syrup, so the agricultural lobby would most likely disapprove. Fortunately, science has provided an answer to our little conundrum. Enter shade balls. The concept is simple. Cover the surface of a body of water in small balls that help slow down evaporation. They've been used in LA and the American Southwest to help limit evaporation in water reservoirs needed for public water supplies. The balls are made of HDPE, a kind of plastic, and an additive added to make them black. And of course, that begs the question, what would happen if we filled the entire ocean with these? Like the entire surface of the ocean just covered in beautiful black balls. Could we do it? And would we reduce evaporation enough to prevent all inclement weather? Let's look at our assumptions and get into some math. So let's start with our knowns. So the diameter of these shade balls is about 10 centimeters or 0.1 meters in diameter, just ripped from Wikipedia. So yeah. The surface area of the Earth is 361 million kilometers squared. Also just ripped from surface level internet Wikipedia. And the weight of these shade balls is 0.1 kilograms or 100 grams. And I took a lot of the calculations I'm going to be using here from a Nature article, which I'm putting in the description, the link to that. And I know what you're probably thinking. Nature's a rag magazine. It has no influence in the scientific community. It's basically a tabloid. And that's completely 100% correct, but I don't want to have to look up equations or values. They have it in this article, so I'm going to roll with it. Okay, so the packing ratio of these shade balls, we're going to say it's 0.70. Nature gave us a range, but I'm going to pick the middle of that range, which is what an engineer does, just approximate everything. Okay, so these spheres are going to block an area of sunlight equal to their area at their widest, bulgiest, meatiest point. So we can model the space each one takes up by simply calculating the area of a circle. It doesn't matter the testicle shape, as far as I know, you're looking from them overhead. So everyone is essentially a circle. So finally, here's the money shot. We're going to calculate how many balls we would need. So the surface area of each ball is pi times 1/2 of the diameter squared. You learned that probably in middle school. And that gives us 0.008 square meters per ball. So dividing the water surface area of the Earth by the surface area of the ball, we get 4.596 times 10 to the 16th balls. And earlier I stated that that was the surface area of the Earth. That is the surface area of the Earth's oceans. My notation is just dog shit. Okay, so yeah, that's a lot of balls. 10 to the 16th is a really big, unfathomable number. But these are really small balls, so let's see if it'll still work out somehow. So let's look at the mass of HDPE plastic we would actually need. So the weight of all of that plastic would just be the amount of balls that we're going to have times the mass of each ball, and that gives us 4.596 times 10 to the 15th kilograms. We'll put that into metric tons because I just need that number to be a little smaller and not have a unit, even if it means the exact same thing. So 4.596 times 10 to the 12th metric tons. So all of these balls, all of this plastic, it kind of begs the question, would this even stop enough evaporation to prevent hurricanes and other inclement weather events? So when they were doing this in the LA reservoir, I can't speak English, they found that it prevented 85 to 90% of all evaporation. I have a link to that article in the description. Now, that's a lot. That's probably more than half of all the evaporation on Earth. So it's going to have a significant effect. On a climate scale, that's a massive decrease and would cause a bunch of cool and also unpredictable consequences. Reducing almost all evaporation across the ocean could, theoretically, essentially eliminate all sources of terrestrial fresh water on Earth and cause a global drought that would cause apocalyptic mass famine, theoretically. But the hurricanes would almost certainly stop. And consider this, when we reduce the amount of evaporation that's occurring on Earth, we are going to reduce the amount of water vapor, which will reduce the amount of clouds. And if there's less water vapor in the air, less clouds in the sky, that means less greenhouse gas. Water contributes greatly to the greenhouse effect. So if we get rid of all of the water, we have more room for CO2, which is much better, and we can also reduce the overall greenhouse effect. At this point, some of you nature-reading idiots might say something like, "Oh, Staircase, wouldn't fewer white puffy clouds result in less light reflection from the sun and increased temperatures?" As a dignified man, I will not answer loaded questions designed to sully my grand plans with logic. If you like clouds so much, go live in the UK and make love to one, but keep them out of my YouTube video. I'm sure I'm also going to get comments like, what about the people who rely on rain from existing weather patterns to grow their food? This is also an extremely dumb comment. They can use foreign aid to buy barrels of high fructose corn syrup, which will sustain them far better through its superior caloric density. Now, back to the program. We can see that eliminating water vapor will be immensely beneficial to humanity. But here's the issue. Making that many shade balls will be unbelievably expensive, and today's leaders don't care about protecting our environment. Most of them don't, at least. One nation has actually made unbelievable strides in putting my plan into action. We have not communicated personally on the matter, but I'm sure we share the same motives. This group has found a way to economically create this evaporative shield while stimulating the global economy. That's right, the People's Republic of China. Every good story has a surprise hero that no one expects. But how is the PRC carrying out this great plan? Well, does anyone remember the Great Pacific Garbage Patch? That's right, that wasn't some negligent monstrosity created by China and other high consumption economies. It's the beginning of a cheap plastic shield around the ocean. And to top it off, it costs nothing to make and assists us in waste management. So how much trash would it take to shield our oceans? This is a much harder question, as trash is not uniform like our cute little balls, but let's assume we can achieve a major evaporative reduction with about a 1 centimeter or 0.01 meter thick layer of trash on the ocean surface. This will not be as effective as the full shade balls, and ocean currents will move the trash around, but we don't really need perfection here. Even a small reduction in evaporation will give us some pretty big results. So, multiplying our desired beautiful layer of trash at 0.01 meters multiplied by the surface area of all the oceans on Earth, we get 3.61 times 10 to the 12th meters cubed. So, how much trash would that require in terms of weight? Well, let's assume that all plastic is 970 kilograms per meter cubed, which is just kind of like a rough estimation for plastic. We're also going to assume that all trash is plastic, because I hate math and I hate thinking. So in that case, we can just take the volume of trash we need, multiply it by the density, slam bam, thank you ma'am, 3.5 times 10 to the 15th kilograms of plastic trash required. We'll turn it into tons because I'm a child, and we get 3.502 times 10 to the 12th metric tons of plastic trash required. Now, the world produces 3.5 times 10 to the 8th tons of trash every year. I pulled that from Our World in Data, again, in the description there. And when we take the amount of years that will be required to make all the trash we need using this number, we get 1 times 10 to the 4th years. Now, that's obviously an insanely high and unacceptable number, and that doesn't even take into account the fact that most of that waste goes into landfills, or even worse, it gets recycled. So this is already assuming our leaders get a clue and start dumping it where it belongs, in the open ocean. But even then, it's going to take 1 times 10 to the 4th years. Now, put into human terms, that's 10,000 years. And that's a long time. But think of it this way. We could reach 1% of that in just a century. And with more advances in pollution technology in our lifetimes, we could see even more than that. Your grandchildren will live to see tiny plastics fluttering through the azure waves of the Atlantic, like tiny dreamlike beings, holding the ravages of an enraged sun at bay. We can live in paradise, but only if we are brave enough to claim it. So, call your congressman, start a rally, make your voices heard. We can change the world for the better, one Taco Bell spork at a time. Hystericus signing off. Do the right thing.